boys and girls. Thank you for having me back here on TUSDtv. Mrs. Virgo here, and again I brought my companion, the grad scientist. Can you just wave hello, please? So I'm glad you are back with me today. And the last time we were together, we were talking about the properties of water. We learned a lot about surface tension and cohesion, and how surface tension is created by water molecules, and how the hydrogen bonds form at the top of the surface tighter, and it creates almost a hard shell, and that explains why bugs can walk on water. Very interesting. And cohesion is the water molecules sticking to water molecules. So with those concepts, I thought we'd have a little bit of fun today. We were going to talk about adhesion, and I mentioned that last time, but I think we're going to save that for next time, because on the way here, you're not going to believe what happened. I was driving down the road and a sprinkler sprayed water onto my windshield. Yes, it did. And you know, I happened to notice that the water drops stayed on the window. I could see these water drops, and made me think about what we practiced last time. Okay, water molecules were sticking to water molecules. So it gave me the idea that we can have some fun with that concept. So today I'm going to first tell you some of the materials we will need for today's little experiments. We're going to do something called the water stretch. And for the water stretch, basically you just need a little pattern, and I'm going to tell you in a minute how you can create your own. And we're going to do a water race, and you can race against people in your family, a lot of fun. And we are also going to talk about how we can make mazes out of just using a pencil or paper and water drops, and have a lot of fun. So anyways, the materials you will need are a piece of wax paper like last time. Again, you can use parchment paper, you can use tin foil, you can use plastic sleeves. So different ways to use things around the house for this concept. Always have a paper towel or something that you can clean up your mess with. And again, a variety of water droppers for putting your water down. So here we go. Let's get started here. For this, all I did was I traced a quarter, and I used a ruler to make lines. And I just marked centimeters. Okay, so I have a starting place and I have a finish line, almost like a race. Okay, so I'm going to slide that under the wax paper like this. Okay, and then I will take my water. I'm going to use the smaller dropper here like this. So I'm just going to put a little water in here, and I'm going to fill the bubble here, the size of my quarter. And last time we counted how many drops it would hold. I'm not going to count because we have a pretty good idea, but what you do want to do is you want to make it the size of the whole circle. And you're going to notice it slides, it does some silly things. If you notice your water moving and doing some silly things, make an observation and see if you can make connections to why it's doing that. Talk about surface tension, and talk about cohesion, water molecules sticking to water molecules. So here we go. It's time to make a prediction. I'm going to take a toothpick, and I'm going to stretch the water. Do you think I will be able to do that? Think about that. Will I be able to stretch that? Everyone make a prediction. Excuse me. Hello? Hi, Grayson. Yes. Yes. Okay. Do you have your water drop there? Mm-hmm. Okay. So you predict the water will not move. Very interesting. Thank you, Grayson. Watch and find out. Okay, so Grayson, excuse me. Hello? Hi, Sierra. Okay, you don't agree with Grayson. What do you predict will happen? The water drop will break up into many drops. Okay. Watch and see what happens, and make sure you can do this along with us at home. Okay, so we have two different predictions from Grayson and Sierra, so let's find out. Okay, I'm up to 3 centimeters. It's still holding. Oh, it moved off the circle. I'm going to move it back. Did you notice how it stayed together and it moved back? Let's try this again. 3, oop, the whole thing's moving. Maybe if I turn my toothpick sideways. 5, let's see, oh. Ooh. Okay, so that was very interesting. I have seen students be able to stretch their water drop up to 9 centimeters. Try that at home and see what you can do, okay? So I'm going to sop up my water. And I have another idea. I'm going to take another one. And I could put these side by side. Or I can put them going the opposite direction, where I could have my mom or dad or cousin, your brothers, your sisters, somebody do this along with you, whoever's at home with you, and you're going to race this time, okay? So you're both going to put your water drops in the circle. I'm going to fill that one right there, the size of the circle. I'm going to fill that one right there, the size of the circle. I can really observe the surface tension. Make an observation. Now make a prediction. Straws. If you don't have straws, be creative. Roll up some paper, find another way. I know a lot of people are protecting the environment, so they're using reusable straws that fold out. Just something you're going to blow through. So I'm going to use a straw, and if I was racing against someone, they would have their own straw. Okay, so if I were to blow, and you can see my straw in my water, if I were to blow, what would happen? Time for prediction. Excuse me. Good morning. Carson, hi. You don't think I will be able to race. Why not? Oh, my water drop will blow up. That's very interesting, Carson. Are you trying this at home? Nice. Well, remember, you can always pause. Yes, you can pause the station so that you can get ready and race with me. Okay, thank you for calling. Carson thinks it's going to blow up. In science, sometimes that happens. Things just blow up. Okay, so, excuse me. Good morning. Hi, Brian. You want to make a prediction. What will happen if I take the straw and blow on my water bubble? It'll move. Okay. Do you think it'll move straight, or you think it'll move in different directions? Okay. Yes, and those are called variables. A lot of it depends. All right, thank you for calling. Okay, so here we go. Are you ready? Set. Eyes on my water bubble, and go. Oh my, it blew up. Okay. Remember, we talked about science, more than one try. What happened? No, I'm not going to ask the grad scientists. I need to think about my knowledge and what I know. I think what happened is I had a lot of pressure with my blowing and too much air, and it broke the surface tension. I'm going to prove that by trying it again. I'm going to fill my circle again. Okay, are we ready? Okay, here we go. Ready, set, go. Putting them back together. And there we go, across the finish line. But I hope you made some observations how my water drop broke. I was able to put it back together, and it clung back together. That's cohesion. The water molecules, the hydrogen bonds grabbing together. Okay, so you can take this and you can race each other. You can time each other. How long did it take you to get to the finish line? How many times did it break? Make some observations. Talk about the variables. Does the size of the straw make a difference? Does the speed of the air make a difference? The distance, the size of your water drop. So use those variables and make some comparisons. A lot of fun. And one more thing with our knowledge of surface tension and cohesion, I want to share, very similar, is I made a maze. Okay. So for the maze, again, I took a quarter and I just drew just kind of a curvy road almost, because I want to see if I can have enough control of my water bubble to direct it where I want it to go. And again, you can race with each other. Okay? Instead of giving too much away, I want you to try this at home. And you can create obstacle courses. You can race with someone else. You can time yourself and see if you go faster or slower each time and make observations of what happened. Because this is science and we experiment and we do things multiple times. So just have a lot of fun with it. I want to sign off and tell you thank you for joining us, and thank you for joining the grad scientists with me. Thank you for being here, and we will see you next time.
Amazing.
And I love being
What
here.
Fun.
What would happen?
Don't
Don't touch that. I
I-
got it.